I will start off with the HDI, which is the hydrogen deficiency index, where we are generally supposed to follow this this formula. So as you can see, I just plugged in the number of carbons, which is 10, the number of hydrogens, which is 11, and the number of iodine, which is 1. Oxygen does not need to be put into this formula. So the hydrogen index that I got was 5, hydrogen deficiency index. Next, moving on, we have the infrared spectrum. So over here, we can see right off the bat a distinctive, strong peak at 3000, which tells us there is a CH single bond sp3 hybridization. So that's at 3000. In the triple bond region, we don't see much action going on, so we can skip over to the double bond region, where we have once again a very distinctive peak that we've been over many times. Now it would be a carbonyl group, so a C double bonded to an O. That's found at approximately 17-15 centimeters. Over here we have the fingerprint region, so we will discard that. And what we can see overall from the infrared spectrum is the CH-sp3 hybridization, as well as the carbonyl group, C double bond O. Next up, we're moving on to the carbon-13 NMR and the hydrogen NMR. So since this video is meant to be brief, I will briefly go over what information I have already put in. So referring back to the charts for the carbon 13 NMR right over here, we can see NMR, carbon 13, right over here. So according to this chart, we can see that over here we have an alkyl group. So there's evidence of an alkyl group. There's evidence of a heteroatom, so carbon attached to a heteroatom, an ester ether or an alcohol. 3 peaks for the carbon double bonded to another carbon, so carbon-carbon double bond. We know there are going to be 3 of them, as well as 1 group as such. Next, we have our hydrogen NMR. We have an alkyl group. So what this tells us is that there is hydrogen within this environment. So a hydrogen within this specific environment has 4 neighbors. So that means 4 other hydrogens of the same environment, of a different environment. And that would be, that falls within the group of carbon double bonded to another atom, which is not a carbon, most probably. Over here, what we have is the aromatic ring. We can see 2 different hydrogens of different environments, which have 1 neighbor each, and they are considered doublets. So putting all that information together, the molecule that I got looks like such. It has a benzene ring. It has a heteroatom, which is the iodine over here. It has a carbonyl group. It has an ether, which we had identified right over here. And it has an alkyl group, as we identified over here. So this is consistent with the information given to us above. And last but not least, the way that we can confirm this is that the HDI is 5. We can see that there is 1 benzyl group, so 1 aromatic group, plus 3 pi bonds, plus another pi bond over here. And that will give us a total of 5.